Hi everybody. So in this video we're going to be talking about topic 9.4 from chapter 9, tangents and normals. And we'll start with example 9.15, and it says find the equation of the line tangent to y equals square root of x at x equals 9. Use this tangent line to approximate square root of 10. Okay, so the first thing we need to recall is something called the point slope formula for lines. So the point slope formula says that if I have a slope m from a line and a point x1, y1 that lies on that line, then the equation can be written as y minus y1 is equal to m times x minus x1. So in order to find the equation of the line tangent to y equals square root of x, we need the slope and we need the point. Okay, so for the point, we can just use the fact that x equals 9. So when x equals 9, y of 9 is equal to the square root of 9, which is 3. That means that we have the point 9, comma 3. And that is the point of tangency, where they want us to find the equation. So for the slope, we need the derivative. Remember that the derivative of square root of x is like considering the derivative of x to the power of 1/2. So notice that this is the same as 1 over 2 times square root of x. So with this we can find the slope, because at the point x equals 9, we plug that into the formula for the derivative, and we're going to get the slope at the point 9, comma 3. So this is going to be equal to 1 over 2 times the square root of 9, and this is obviously 1 over 2 times 3, so this is going to be 1 over 6. So this is the slope m. Okay, so we're already all set to write our equation, right? So y minus y1 would be y minus 3 is equal to m, the slope, 1/6, times x minus x1, which is 9. And then we have that this implies that y is equal to 1/6 x times, okay, so this will be 1/6 times negative 9 is going to give us negative 3/2 plus 3. It's going to be positive 3/2. So 1/6 x plus 3/2. So this is the first part of the problem, which is finding the line of the equation for the tangent line, right? So now we have to approximate square root of 10. So remember that if you have the graph of the square root of x, if this is the graph of square root of x, remember that those graphs look more or less like this, right? It's just a line that raises very, very slowly, and it has a curvature that is downward. So when they say approximate the value of square root of 10, it means use the tangent line to find that, right? Because the tangent line at the point 9, comma 3, which would be here, this line of tangency, must also go very close to what would be the square root of 10. The square root of 10 is approximately 1/6 times 10 plus 3/2. And this is going to give us 19 over 6, which is 3.16. And this number goes on forever. Now, if you plug in square root of 10, you're going to see that it's exactly this to 3 significant figures. Okay, so now we are in example 9.17. It says, consider the function g of x equals x squared times x minus 1. Part A, find the 2 points of the graph of g at which the gradient of the curve is 8. Okay, so notice that we can rewrite g of x as x cubed minus x squared. And this makes it easier to differentiate. We won't have to use the product rule. So the derivative of g of x is going to equal 3x squared minus 2x. So it says find the 2 points at which the gradient of the curve is equal to 8. So remember that the gradient of the curve is always given to us by the derivative. So if we equal this to 8, we will be able to find those 2 points. And notice that this is quadratic, so we can rewrite this as 3x squared minus 2x minus 8 equals 0. And then if we factor this, this is the same as saying 3x plus 4 times x minus 2 equals 0. So that means that for minus 4/3 and for 2, we will have a gradient of -8, or of 8, positive 8. So we still have to find the y coordinate for the 2 points, because this is only the x coordinates. So we have to do g, back to the original function, right? G of -4/3, which is going to be -4/3 cubed minus -4/3 squared. And if we do the math there, we are going to get minus 112 over 27. And then we need to do g of 2. So g of 2 will be equal to 2 cubed minus 2 squared, and that's 8 minus 4, which is 4. So that means that we have the 2 points. And the 2 points will be -4/3, comma, -112 27ths, and 2, comma 4. So now we're going to do part B. Okay, so for part B, it says find the equations of the tangents to the curve at both these points. So this is the easier part, because we have all the information we need. We know that the slope of both lines is the same, which is 8. And the points that we got were 2, comma 4. And the other point was -4/3, comma, -112 over 27. So with this information and knowing the use of the point slope formula, we can solve. So for this one, we get that y minus 4 is equal to 8 times x minus 2. And if we expand and rearrange, we're going to get that y is equal to 8x minus 12. And then the same thing for the other one, right? We're going to go y minus minus, so y plus 112 over 27 is equal to 8 times x minus minus, so plus 4/3. And then if we expand and rearrange, we're going to get that y is equal to 8x plus 176 over 27. So on the next slide, you're going to find the normal to a curve at a point. So the normal is just another line that goes through the same point that a tangent would. The only difference is that the normal is perpendicular to the tangent at that point. So for instance, if the tangent has a slope of m1 and the normal has a slope of m2, because they're perpendicular, we know then that m1 times m2 is equal to -1. And this is what we need to use in order to find the equation of a normal. So in example 9.18, they ask us to find the equation of the normal to the graph of y equals 2x squared minus 6x plus 3 at the point 1, comma, -1. So we proceed to do the same thing. First of all, we need the derivative in order to find the slope of the tangent. So we would say, well, the derivative of y is going to equal 4x minus 6. So once we have this, and we know that it's at the point 1, comma, -1, the slope of the tangent would be equal to plugging in 1 here, right? So this would be 4 times 1 minus 6, and this equals -2. But this is the slope of the tangent, and we need the slope of the normal. So all we have to do is say, well, -2 times the slope of the normal is going to equal -1. And solving for m2, we get 1/2. And obviously it is, because -2 times 1/2 is -1. We have all the information we need so that we can write the equation of the normal line. So it's going to be y minus minus 1, referring to this point here, y minus minus 1 is equal to 1/2 times x minus 1. And if we expand and rearrange this, we're going to get that y is equal to 1/2 x minus 3/2. Very well, so here we are in example 9.19, which is the last one on this video. So it says, consider the parabola with the equation y equals 1/4 x squared. Letter A, find the equation of the normals at the points -2, 1 and -4, 4. So let's do that first. Obviously, we need the derivative, just like we've been doing before. So the derivative of y is simply going to be 1/2 x. Okay, so at the point -2, 1, we would have that the slope of the tangent would be equal to plugging in the derivative -2, and that's going to be 1/2 times -2, which is -1. That means that the slope of the normal is going to equal 1. Why? Well, because -1 times 1 is -1. So we have everything ready for the first equation. The first equation then would be y minus 1 is equal to 1 times x minus 2, so x plus 2, and then that means that y is equal to x plus 3. So this would be the first equation. So now we'll do the second equation. So the second equation is at the point -4, 4. So in the same way, we plug the -4 in the derivative, plug in -4, and we're going to get 1/2 times -4, and that's going to be -2. So that means that the slope of the normal has to be 1/2. Now with this, we can just write the equation. So it's going to be y minus 4 is equal to 1/2 times x minus 4, so x plus 4. And if we expand this and rearrange, we're going to get that y is equal to 1/2 x plus 6. Okay, so now we're going to do part B. Okay, so in part B, they ask us to show that the point of intersection of these two normals lies on the parabola. Okay, so the point of intersection of the normals, remember that the normals we found were y equals x plus 3 and y equals 1/2 x plus 6. So we need to find the point of intersection and then show that it lies on the parabola. So the point of intersection is going to be the solution of a system of equations, right? So we have y equals x plus 3 and y equals 1/2 x plus 6. We can do a substitution and just say that x plus 3 is equal to 1/2 x plus 6. We solve for x, and we're going to get that 1/2 is equal to 3. 1/2 x, sorry, is equal to 3. Therefore, x is equal to 6. All right, so if x is equal to 6, that means that y is equal to 6 plus 3. So y is equal to 9. So that means that the point of intersection of the two lines is 6, 9. Now we have to show that this lies on the parabola. That's very easy. All we have to do is plug in 6 in the parabola and see what we get. So y of 6 is equal to 1/4 6 squared, and this is going to be 1/4 of 36, and that is 9. Therefore, we have shown that the point of intersection of the two normals lies on the parabola.